Welcome, dear students. This is your probability lesson 6, and here we are going to talk about objects, or rather arrangement of objects in a row. So we're just going to put some objects in a row and figure out in how many ways we can do it, and if some things have to be together, then how do we do it, and if certain things do not have to be close to each other, how do we still do that one? So to start with, let's have example 1. So here we are being told that we have 5 people that are seated in a row, and then we are being asked how many ways they can be seated. So it's 5 people that are seated that would like to sit in a row. So if there are 5 people, let's make 5 places. 1, 2, 3, 4, 5. So from what we already know, if we have these 5 places and we have 5 people to fill it, so it's more like 5 permute 5. So for the first position, you are choosing from 5 people. Then for the second position, they are reducing to 4, since human beings cannot sit at 2 places. So in this situation, it's more like repetition is not possible in actual fact. So there is no repetition here. So for this one, there are 3 options, 2 options, and then 1 option for the last one. So in short, we say that this one can easily be called 5 factorial. I believe you can see that this will be 120 ways. All right, that's the first one. So now what about the second way of doing things? So he says, how many ways are there if 2 of the 5 insist on sitting next to each other? You will notice that I will use these little sticks to represent the people that we have. So here we have 5 of them. So let us just say these 2 here insist on sitting next to each other. So what we do is we make them into one entity. It's one object now. So we're going to make them into one object. And when we do, we now only have 1, 2, 3, 4 objects to arrange. So if we would like to arrange 4 objects, you arrange 4 objects in 4 places to sit. So you arrange them in 4 factorial ways. But then you will have to multiply that by the number of times you can arrange these 2 people that are sitting next to each other. So these 2 can sit, maybe this person may want to sit on the left-hand side at first, and then for the second time they may want to sit on the right-hand side. So those are the 2 possible options for those 2 that are in a box. So you will have to multiply your 4 factorial by 2 factorial. So it means if there were 3 people in a box, you are going to multiply it by 3 factorial. If there were 4, then you're going to multiply by 4 factorial, like that, because that will be the number of ways in which you arrange the things that we enclosed as one entity there. All right, so if we can do that, then getting 4 factorial times 2 factorial should not be a problem at all, especially if you have your calculator. So this would just be 48. So consider this your first example. Let me give you a second one. And I'm giving you a long one at that. So let's say we have a situation such as what we find ourselves in now. In how many ways can 5 boys and 4 girls sit in a row? So altogether 5 plus 4, I think you're noticing that we have 9 people here. So we would like to answer these questions. Let me create more space for it. So for number A, I would like to say if we have 9 people that we're going to ask to sit so let me say this is your bench right here, or in a row, 9 places if you must. 2, 3, 4, 5. Okay, so those are the 9 places, and remember there are 9 people that have to sit. So for the first position, 9, you are choosing from 8 now, and since 2 people are seated, there are only 7 choices you have. Now 6, 5, 4, 3, 2, 1. You don't have to do this box, especially if you now understand what's going on. So I think you will just go straight to saying 9 factorial, and 9 factorial is 362,880. So this right here will be the solution for A. Now let's go and answer question B. The question says, in how many ways can they sit in a row if a boy and his girlfriend must sit together? So like I did before, let's just have these 9 people. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9, the boys and girls. I used the same color for both of them. So let's just say this was I don't have to put the girlfriend and the boyfriend at the beginning. By the way, they are allowed to move wherever they want. So let me just say this was the boyfriend and the girlfriend. So they want to sit there. And if they want to sit next to each other at all times, that will reduce the number of possible outcomes that we get. So we put them as one entity or as one object. And now as we count our objects, we can see that 1, 2, 3, 4. So we count it as one object. That's 5, 6, 7, 8. So we now have 8 objects to arrange. So how do we arrange 8 objects? That's 8 factorial ways. But the thing is, there are these 2 that are together, and they have 2 factorial ways in which you can arrange them, like I've already explained. So this answer will be 80,640. That will be the solution for that. Okay, I hope you're grasping the concept. So let's go to C, and so you can see if you're getting it. In how many ways can they sit in a row if the boys and the girls are each to sit together? Oh, so the boys want to sit on their own, and the girls would like to sit on their own. So let's just say here we have boys. So how many boys did we have initially? 5 boys. 1, 2, 3, 4, 5. Those are the boys. So we would like for them to sit together. So they become one object or one entity, like I've already explained. And how many girls? We know that we have 4 girls. So that's 1, 2, 3, 4. Let's put those ones in one entity as well. So how many objects do we have to arrange in this situation? It does look like everyone is enclosed in a box. So we have 1, 2 objects to arrange. How do we arrange 2 objects? Well, we arrange them by saying 2 factorial ways. But the thing is, in these boxes, we know that there are these 5 boys. And since there are 5 in that box, in that entity rather, we know that we can arrange them in 5 factorial ways. So we have to multiply by it. And then as for the girls, there are 4 of them. We can arrange them in 4 factorial ways. So this right here will be how you solve this. Now, what will be the answer to this? That will be 5,760, like that. Okay? Now let's go and carry on. Let's see if you're getting it. In how many ways can they sit in a row if just the girls are to sit next to each other? Do you still remember how many girls we have? Well, we remember we said there were 4 of them, right? So these still have to sit next to each other. So if I still put our 5 boys, but this time these boys want to, and by the way, they don't necessarily have to be on the same side. It can simply be 3 this side and maybe the other 2 boys that side. The boys did not say they wanted to sit next to each other. We can just put them anywhere. So let's just say these were the positions that we had. As you can see, girls are sitting together, the boys are not. So how many objects do we have to arrange? That's 1, 2, 3, 4, 5, 6 objects this time. How do I arrange 6 objects? That cannot repeat. So that would be 6 factorial ways. After I arrange them in 6 factorial ways, now I go to my entity, or that box of ours, which has how many things? As you can see, it's actually 4 things inside. So then what will be our solution for that? We have to multiply by 4 factorial. And when we multiply by 4 factorial, we get 17,280. So that will be the solution for that. Okay, these are examples. So I think at this point you should start to get where we are going with these arrangements and how I am doing it at all. So at this point you must now have an idea. So let's go to E, this one over here. It says, in how many ways can they sit in a row if just the boys are to sit together? Okay, so in this situation, these were the girls, isn't it, that were sitting next to each other. So now the boys would like to sit next to each other. So it's 1, 2, 3, 4, 5. We have 5 boys, so they want to sit together. So I'm just going to put them as an entity right there. And then the other girls, so this is how the girls will sit. So 1 this side, the other 3 this side, let's say. So this is one arrangement, since there are 4 girls. So since these ones are seated like this, remember this is 1 object, 2 objects, 3, 4, 5 objects. Now we have 5 objects to arrange, and we arrange them in 5 factorial ways, and afterwards we check our box to see how many things we enclosed in there so that we can take that into consideration, the arrangement of those into consideration. So that will be 1, 2, 3, 4, 5. So we have to multiply by 5 factorial as well. The number of ways in which those boys can arrange themselves while they are sitting next to each other. So that will be 5 factorial times 5 factorial. I am getting this big number here. Okay, 14,400. That will be the solution for that. Okay, so let's go to F, since these are still examples. In how many ways can they sit in a row if the boys and girls are to alternate? Oh, you have to be careful with this question. Remember, we have 5 boys and we have 4 girls. So when we are told alternating, it means a boy, girl, like that. So that's alternating, right? But you have to be careful who should start this thing. Who should be at the beginning at this point? So from what I'm looking at, since we have more boys than girls, this option will work better. Boy, girl, and another boy, then girl, there's another boy. How many boys do we have so far? 1, 2, 3, 4. So we still have to let one sit. So now there are 5. So this will be the arrangement that's possible in this situation. As you can see, we have these girls that are here, a girl there, and a girl over there. So instead of the boxes, I'm putting these BG going on. So notice what was going to happen if you decided to start with girls. So you're going to have a girl, then a boy, then a girl, then a boy, then a girl, then a boy, a girl. So notice now how many girls? 1, 2, 3, 4. So the girls are done. Now the boy, there is still another boy. So notice how you are going to be forced to put these 2 boys next to each other. So we won't be alternating anymore. So this starting with a girl is not going to work. So if you have 5 boys and then you have 4 girls, when they ask a question such as when they alternate, please start with the one that has got a bigger number. All right, so let's start with the boys. I want for the boys to sit now. So these are the positions for the boys. So I want to put the options we've got for them, okay? So for this first chair of mine, how many options am I choosing from? I think you are saying 5, since we have 5 boys. 5 boys. For this one, there are 4 left. For this one, I'm choosing from 3, and then 2, and there is just that 1 boy. So we know that those will be the correct values for boys. Let's go on the girls' part. Well, on the girls' part, at first, for this seat here, there will be 4 options, and then now there are 3 options, now there are 2 options, and now it's 1. Well, as you can see from what we know from counting principles, all you need to do is to multiply your options that are available for you to get your solutions. So these are all the options that are there, we wrote these numbers. So all you need to do is to multiply everywhere if you must. So multiply these options and see the answer you get. By the way, it's the same as saying 5 factorial times 4 factorial if you look at it closely. Okay, so I am getting 2,880 myself. Okay, so that is the one that I'm getting. Perfect. That is the second example. I think you have what is needed to start answering these things on your own. So I'm going to give you this first practice question. So please answer it first before you see how I'll solve it. Okay, well done if you tried it. So we have some weird people here, some weird names. So we have some Jairds, the Ruckers, Garrett, Matope, Fishana. All those people are there in a hockey team. As you can see, it's 1, 2, 3, 4, 5 of them, right? So these are the 5 people that are in a hockey team. So they are sitting on a bench waiting for their turn to play. But here is the thing. Jed and Rakas are sitting next to each other. So this is the thing. So we have those 5 people that are sitting, but these ones would like to sit next to each other. So this will be Jed and that will be Rakesh, if I must. So we said that we arrange them like this. Okay, so we put them in a box like what I've just finished doing, and then figure out how many different ways can these boys be arranged on a bench, especially if those two guys would like to continue sitting next to each other. So now you count the number of objects you have, and that will be 1, 2, 3, 4. You arrange them in 4 factorial ways, and don't forget about those 2 that are together, and since they are together there, you multiply that by 2 factorial. So that's what we agreed, isn't it? I think that was simple enough for you. I am getting 48. You don't even have to break a sweat when answering a question like this. Let's give you another one. Try that one, please. Well done if you tried it first. So here we have 6 different mugs. So we have 6 red mugs and 5 blue mugs, and we have, what else? 6 red and 5 different blue mugs that have to be arranged on a shelf this time around. So it's also a row of some sort. How many arrangements are there if all the red mugs are put together and all the blue mugs are put together? Oh, so in this situation, these are the mugs, so they have to be put together. So unfortunately, they're in a box from now. And then we have 5 of those mugs. So these are the mugs. We put them together. So once they have to be together at all times, we were not told that the blue ones should be to the right and the red ones should be to the left. That is why we cannot say there is one way of doing it. Rather, we say that we have 2 objects to arrange. So how do we arrange 2 objects? By saying 2 factorial ways. We can arrange these by saying 2 factorial ways, but then after we arrange the big boxes we've got in 2 factorial ways, which is just 2 ways, then we have to consider the things that we enclosed, people. We enclosed 6 red mugs, and those ones can be arranged in 6 factorial ways in their positions. And then we also enclosed those many mugs. Those blue mugs, how many were there? It's 5 of them. So they can be arranged in 5 factorial ways. So if we want to know how many things are there, eventually you will have to multiply 6 factorial and 2 factorial and then 5 factorial there. So I am getting 172,800. That's what I'm getting for this one. So I hope you got the same solution. Okay? Well done if you did. Now let's go to your practice question 3 to see if you're grasping this concept. So what do we have here? It's 7 boys and 6 girls are to be seated seated randomly in a row. What is the probability? You see, these are now calculations that involve probability. So when you have calculations that involve probability, you first of all figure out what your sample space is. Remember anyway that the probability of an event happening is the number of times that event is taking place divided by the total number of possible outcomes in that sample space, okay? So here, notice 7 plus 6. That would be like 13 people that we've got here, right? So the question is saying, what is the probability that the row has boys and girls sitting in alternate positions? So if I want to really answer this properly, I may have to first of all talk about the possible outcomes, because NS is actually the number of possible outcomes, you know. So if I am going to sit 13 people in a particular row, and there is no repetition that is possible here, so the number of possible outcomes here will be 13 factorial. Can you see that? So that will be 13 factorial, really. I may simplify this to a value, but actually to be easier to work with is 13 factorial. So let me just get it on my calculator quickly. Oh, this number is just impossible, like this one. Okay, that's a lot. 702 some 0800 like that. So that's 13 factorial. I believe I'm going to use it as 13 factorial. It will work better for me. Okay, so now since we know the NS part, we can now find out what they want. So we want to find out that the probability that the row has boys and girls sitting in alternate positions. Okay, we just learned how this is done. So since there are 7 boys in this situation and 6 girls, I think you would like to start by a boy. Then you go girl, a boy, a girl, a boy, girl, boy. You know, how many are they? 1, 2, 3, 4, 5. Oh, we still have to put that one, really. Okay, so how many girls do we have? It's 1, 2, 3, 4, 5, 6. We are sorted. We don't really have to continue to do this because we know that for boys, since I'm choosing from 7 boys, we know that this will be 7, 6, 5, 4, 3, 2, 1, the number of options that I will have for this. So you can as well just write it as 7 factorial from the beginning. But if you must look at it and understand why 7 factorial, then also do this in your head, or you may write it down like me here. I'm writing it down because I have to explain things. Okay, so those were the options. For girls, we know we are choosing from 6 girls. So at first we have 6, and then we are choosing from 5, then from 4, then from 3, 2, and then 1. And I believe you know that that is 6 factorial, isn't it? So this right here will be the number of times itself when the boys and girls are sitting in alternate positions. That is 7 factorial times 6 factorial. I'm getting a weird, again, a big number, so it does look like it would be easier to work with the factorials, especially if your calculator works just fine. So at this point, I want the probability that these people are sitting in alternate positions, right? So I am going to then say, well, this number here, which I can either write that number or I can just do this, is the same thing. And then I divide it by the total possible outcomes, which we said was 13 factorial. I believe it to be a lot easier on your calculator or on your pen, rather, to do it this way. So this is what I am getting as a simplified answer. Okay? So that's the solution right there. Now, what is the next thing that we have? We are being asked what is the probability that 2 particular girls end up sitting next to each other. So remember, we have what do we have? It's 7 boys and 6 girls. So we have 7 boys and 6 7 boys and 6 girls altogether. So let me just show them like this, so we don't have to worry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it doesn't matter who is sitting where. This is how they may sit. But let's just say there are these girls, let's say these girls that would like to just sit next to each other. The moment they want to all the time sit next to each other, we are not fixing them at any place. We are saying they just want to sit next to each other. So that is why we form a small group for them. So if they are always one entity like that, you will now have to count the remaining number of entities, 7. You just count them once, 9, 10, 11, 12. Okay, something went wrong somewhere. How many? 7 plus 6 was already 13. So then why am I still with 13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I put 1 extra person over there. So I believe you are noticing that now we have 12 objects to arrange, and we have 12 objects to arrange. We also now have to take into consideration these 2. So you have to say 12 factorial multiplied by 2 factorial. Okay, that will be our solution right here. If you would like to use your calculator, okay, go ahead and do it. You should get this one. Okay, but you don't really have to at this point because we still have to calculate the probability that those two girls sit next to each other. Okay, that's what we want. So what do? We take the number of times they were sitting next to each other, which is 12 factorial times 2 factorial, okay, which is this number here, which will be too difficult to continue to write. And then you divide by the total possible number of outcomes. And remember, it was 13 factorial. So if you simplify this, you would definitely get 2 over 13 like I did. Okay? So I hope you're getting it. Right, let's go and finish off this question. It does look like we still have one more that is here. So what is the question asking us? This last question we have to do for this. It's saying the probability that all girls sit next to each other. So we have these 6 girls. 1, 2, 3, 4, 5, 6. So they want to sit next to each other. So we put them in a box. And then the 7 boys, we do not know how they are sitting, but I'm just assuming this will be one of the ways they are sitting. 3 this side and 4 that side. So as you can see, you will now have this number of objects to arrange. Okay? So at this point, it does look like you will only have 8 objects to arrange, and you arrange them in 8 factorial ways. After you arrange those objects that you have now, you go back to your entity, that box that you made, one entity with 1, 2, 3, 4, 5, 6 things inside. How can you arrange those 6 things inside that box? Well, you arrange them in 6 factorial different ways. Well, the solution to that will be this number right here. Okay, so that is the value for that. 8 factorial times 6 factorial. But remember, we would like to find the probability that all girls sit next to each other. Sit together. Let me just say sit together. Okay, so in this situation, it will be 8 factorial times 6 factorial divided by the total possible outcomes. And in this situation, you should get 2 over 429. Okay, I'm sure you got that same one. So please, people, this is when we're doing arrangements of objects in a row, you should know how to do this one as well. So thank you very much for watching this video. This is all I had for you for this one.